In our last video, we talked about quadratic equations and how we can solve them using square roots. All right, we're going to do some more of that in this video. All right, we're going to do a little bit more difficult problems. Okay, before we get there, let's just do a quick reminder. All right, remember, we are focusing on quadratic equations, right? And what that means is that the highest power of x is 2. All right, so it could be something like this. 5x minus 4x squared equals 17, or something like this. 3x squared minus 8x is equal to 0. Right, a whole bunch of different ways we can write these equations, but the key thing is that the highest exponent is a power of 2. Okay, all right, so just keep that in the back of your head. We will work with other types of equations, but for right now we're focusing on quadratic ones, right? And that's because these can be solved using square roots a lot of times. All right, one other thing I want to talk about before we actually get into some problems. Okay, so I want to just talk a little bit about taking the square root of something. All right, so we've talked about the square root of x squared and how that's not equal to x, that's equal to the absolute value of x. All right, so let's talk about what would we get if I had something like this, x minus 5 squared, and I wanted to take the square root of it. Okay, well, so let's think about that. What does x minus 5 squared mean? It means x minus 5 times x minus 5. Right, so if I were to take the square root of this thing, what am I doing? I'm asking what expression, if I multiply it times itself, would get me x minus 5 squared? Right? And you're probably thinking, oh, isn't that just x minus 5? Okay. But actually, we're going to run into the same problem with this that we ran into the x squared situation, right? The square root of x squared is not equal to x, right? This is wrong, because the reason is because this does not work when we have a negative value for x, right? The same thing is going to happen here, right? This is not true if x minus 5 is negative, right? Not if x is negative, but if this quantity x minus 5 is negative. Okay, so the moral of the story is that the square root of this is not equal to x minus 5, it's equal to the absolute value of x minus 5. Right? So another quick example, right? If I had x plus 3 squared, and I took the square root of this, the square root of that would be equal to the absolute value of x plus 3. All right? All right. Okay, so let's solve some of these quadratic equations. Okay, and the general idea is the same, except looks a little bit funny because we have this quantity here. It's not just x squared; it's x minus 2 squared in this case. Right? Well, the first part is exactly the same. We're going to start by trying to isolate this thing, not x squared, but we're going to try to isolate this x minus 2 squared. So how can I get that by itself? Well, in this case, I can subtract 7 from both sides. Right? So I would end up with x minus 2 squared equals 36. All right, now, I don't really want to multiply this out, and it's going to get a little bit messy. But how could I get rid of this power of 2? Right? What I can do is I can square root both sides. Right? So I'm going to take the square root of the left and take the square root of the right. Okay? And let's think about what we get. The square root of x minus 2 squared, it's not x minus 2, it's the absolute value of x minus 2. Right? The square root of 36 is 6. Right? So we end up with this absolute value equation. Okay? We're not quite done yet. We need to solve completely for x. Right? Let's think about what this means. What does this mean? The absolute value of x minus 2 equals 6. Well, this means that x minus 2 needs to be 6 spaces away from 0. Right? So if you look at a number line, right, what numbers are 6 spaces away from 0? Well, 6 and negative 6. Right, so this is saying that x minus 2 could be here, x minus 2 could be here at 6, or x minus 2 could be here at negative 6. In other words, this is saying that x minus 2 could be equal to negative 6, or x minus 2 could be equal to positive 6. Okay? All right, still not quite done. We haven't solved for x yet. Right? So let's deal with our compound statement here. We have got two different equations we're working with. So for this first one, x minus 2 equals negative 6, I'm going to add 2 to both sides. And we end up with x is equal to negative 4. For the other equation, let's add 2 to both sides, and we get the equation x is equal to 8. Okay? And so these are my two answers. X is equal to negative 4, or I should say x is equal to 8. Okay? Those are the two values that if I were to replace x with them, it would make this statement true. All right, you're going to try this one. Now, what I'm going to recommend is for you to do a part of it on your own, and then check in with me, and then pause again and finish it. All right. So what I want you to do here is I want you to try to first isolate this x plus 4 squared. Isolate this x plus 4 squared first, and then check with me. Okay. So pause. Try to get this x plus 4 squared by itself, and then unpause. All right. Did you do it? Did you get x plus 4 squared by itself? Let's see. What I would do first is I would subtract 8 from both sides. Okay. One thing I want to remind you of, you cannot do 8 minus 2 first, right, because of the order of operations. Right. This is a multiplication expression, right? You can't just do this 8 minus 2 here. Right. So I'm going to first subtract 8 from both sides. Then I get negative 2 times x plus 4 squared equals negative 50. Right. I still don't have this x plus 4 squared by itself. Right. What would I do next? I would divide both sides by negative 2. So we get the x plus 4 squared is equal to positive 25. Right? Did you get that? Right? If you didn't, go back and watch it again and make sure you can get this x plus 4 squared by itself. All right. Pause it again and finish the problem. All right. Let's see how you did. All right. Next, I'm going to square root both sides. The square root of the left side is the absolute value of x plus 4. Square root of 25 is 5. All right, so we have this absolute value equation. This is saying that x plus 4 needs to be 5 spaces away from 0. Right? There's two places where that happens. X plus 4, it could either be at 5 or negative 5. So x plus 4 is either equal to negative 5, or x plus 4 is equal to positive 5. Right? If I solve this side, or the first equation, we would get x is equal to negative 9. The second one, we get x is equal to 1. So the two solutions are x could either be equal to negative 9 or x could be equal to positive 1. All right, again, I'm going to have you try to do this one in two parts. Okay, so right now, I'm going to have you try to isolate the x minus 6 squared. Okay, so pause and isolate the x minus 6 squared, and then unpause to check with me. All right, here's what you should have done. You should have subtracted 5 first, and that gives me negative 8 is equal to x minus 6 squared over 2. All right, we still don't have the x minus 6 squared by itself, so what we can do here is multiply both sides by 2. Right, and then we get negative 16 is equal to the quantity x minus 6 squared. All right, hopefully you got that. If not, try it again, or go back and watch it again. Right? At this point, pause again and finish the problem. All right, let's see if you got it. I'm going to square root both sides. The square root of x minus 6 squared, that's the absolute value of x minus 6. What's the square root of negative 16? Well, that's the imaginary quantity. That's 4i. All right, so we have this absolute value equation here. All right. The absolute value of x minus 6 is equal to 4i. Okay. Feel free if you want, you can always rewrite this way. The absolute value of x minus 6 is equal to 4i. That's the same thing. Okay. All right. So what does that mean? Well, that means that x minus 6 could be equal to negative 4i, or x minus 6 could be equal to positive 4i. All right. Last part here. Let's get the x by itself. Okay, I'm going to add 6 to both sides. All right, and what do we end up with? On the left we get x, And on the right, we have this quantity here, negative 4i plus 6. Now let's think about that for a second. Can we combine like terms here? Does this become 2i? The answer is no. It just stays like this, negative 4i plus 6. And actually, we should write it this way instead. We should write it this way, 6 minus 4i. That's in standard form. We want the real part first and then the imaginary part second. Okay. Same thing happens with the other one. If I add 6 here, this does not become 10i, right? We've got a real number and an imaginary number. We can't combine those, right? So we just leave it as 6 plus 4i. Okay. So your final answer, let me rewrite it here so you can see, is two complex numbers, 6 minus 4i, or x could be equal to 6 plus 4i. Right? These are our two possible values for x. All right, I'm going to do this one with you, and then the last one you're going to finish up on your own. Okay. All right, so again, let's try to isolate our x value. Or not our x value, I'm sorry. Let's isolate our x minus 5 squared. That's what we want to isolate. All right, so in this one, let's see, I'm going to subtract 3 from both sides. That gives me 36 is equal to 2 times x minus 5 squared. Next, let's divide both sides by 2. That would give me 18 is equal to x minus 5 squared. All right, here, let's take the square root of both sides. All right, let's be careful here. The square root of x minus 5 squared. That's the absolute value of x minus 5. All right, on the left, we need to take the square root of 18. That's not a perfect square, so let's do this off to the side. Square root of 18. Well, let's break this down. 18 is 3 times 6. 6 is 3 times 2. So that means that the square root of 18 is the same thing as the square root of 3 times the square root of 3 times the square root of 2, which is the same thing as 3 times radical 2. All right, so now we have this absolute value equation. Right? 3 radical 2 is equal to the absolute value of x minus 5. Okay? And what that is saying is that x minus 5 is 3 radical 2 spaces away from 0. Right? Let me draw a little number line so you can visualize this again. Right? So here's 0. Again, this is saying that whatever's in here, this x minus 5, it needs to be 3 radical 2 spaces away from 0. Well, here's one number that's 3 radical 2 spaces away from 0, positive 3 radical 2. But we could also find a number on the other side, negative 3 radical 2. That's also 3 radical 2 spaces away from 0. Okay? So we're saying that x minus 5 could be here, or x minus 5 could be over here. So the compound equation we can write is this. X minus 5 is either equal to negative 3 radical 2, right? That's right here. Or x minus 5 could be equal to positive 3 radical 2, okay, which is right here. All right, so last step here, how do we solve for x? Okay, well, I need to get the x by itself. I'm going to add 5 to both sides. Right? And this just simplifies like this. X is equal to, can't simplify that really well, so I'm just going to leave it as 5 plus, oops, I'm sorry. The bell distracted me, sorry about that. Alright, so we ended up with negative 3 radical 2 plus 5, or that could be written this way, 5 minus 3 radical 2. Or, the other side, we get, if we add 5 to both sides, ignore the loudspeaker, sorry about that, we get x is equal to 5 plus 3 radical 2. So these are my two answers, 5 minus 3 radical 2, or 5 plus 3 radical 2. Last one, I want you to do this one on your own. So pause please and try to do this one on your own. Alright, let's see if you did it. I'm going to subtract 60 from both sides. Okay, we end up with 3 times x plus 4 squared is equal to negative 60. Alright, let's still try to get x plus 4 squared by itself. So let's divide both sides by 3. And we end up with x plus 4 squared is equal to negative 20. Now that I have this x plus 4 squared by itself, let's take the square root of both sides. the left side is going to simplify to be the absolute value of x plus 4, and then the square root of negative 20, if we simplify that, this was negative 1 times 20. 20 is 4 times 5. 4 is 2 times 2. So this is the square root of negative 1 times square root of 2 times square root of 2 times square root of 5. That simplifies to be 2 times I times radical 5. So we get 2 times I times radical 5. Alright, so what does this absolute value statement mean? This means that x plus 4 could either be equal to negative 2I radical 5, or x plus 4 could be equal to positive 2I radical 5. To finish this off, let's get x by itself. Let's subtract 4 from both sides. So we end up with x is equal to negative 4 minus 2I radical 5, or if we subtract 4 on the other side, for the other equation, we end up with x is equal to negative 4 plus 2I radical 5. So those are my two answers. Okay, hopefully you got them. If you're having trouble with this, please be prepared to ask questions about this in class.